All right, for 5.3, we're going to be kind of similar to like we were on the last test. We're going to be solving polynomial equations. Now, here's the biggest thing for this one. Now, again, you still want to try to do factoring first. Factoring is still going to be your best option on all these. Still going to look for common factors, all the different things we've done before. All those parts are going to be in there. We're going to show you a couple of new things at the end that we're going to throw in there, but most everything is going to be factoring still. The one catch that's different on this one is your answers can be imaginary or what we'll call complex, where you got the I variable involved. So for these problems, it may be that you may have an I in the answer, which means when we square root it, you may take the square root of a negative number. So we're going to go back and kind of throw that in there. And similar to like we did yesterday, you still want to look for your greatest common factor first. And we mentioned that yesterday when we were going through some parts on it and solving some different things. Same thing for this one today. Even if you're still solving equations, you still look for the greatest common factor first. So those things are still kind of the same thing that's here. All right, so let's start with one where we're doing x squared equals 25. All right, with x squared equals 25, you've got two options. If you want to do it by solving by factoring, you can subtract the 25 on both sides. But if you ever get just x squared by itself, that's where you can take the square root of both sides. And if you square root x squared, that's going to leave you with just x. If you square root 25, that would be 5. And the only thing we said was that if you start with x squared, we need two answers. If you square root both sides, you can worry about basically include that you've got the positive and the negative. And with the online homework, you should start getting that plus and minus sign on a lot of the problems. They're starting to let you use that more and more. So you can always do that. If you get just x squared equals some number, you can just take the square root of both sides, and just remember you're going to need the plus and the minus for that part to get the two answers you're looking for. Okay, now here's where we're going to talk about the imaginary, just to go back and remind you on these. Let's say you started off with x squared equals negative 25. Still square root both sides. And it seemed like most people with the test I had so far, most people did pretty well with it. The only thing you do different, if it was square root of 25, it was plus or minus 5. If you put a negative in here, the only thing it does to the answer is, there you go, just have to put the I at the end of it. So when you're working through these, especially when you have these problems like this where you've got x squared equals some number, that's where you're going to see the answers more than anything else. If it's the ones where you're going to factor and solve, you don't see that imaginary answer as much. You're going to see that more when you have just x squared by itself, when you start square rooting answers. Okay, so that's just kind of one thing to look for as we're working through some of these problems. We'll throw out something that's a little bit different than that, but based on that same thing where you may get some imaginary answers. For example 3, let's go with x to the third equals 8x minus 2x squared. And this one really kind of looks similar to what we were doing yesterday. Alright, we don't have just x squared in a number, so for this one, this is where you're going to have to basically just kind of factor and solve. And you always, usually the easiest thing to do is to make sure your highest powered term, which in this case is x to the third, if that's positive, it usually makes it easier to solve. So for this one, let's get rid of the 2x squared and move it over here to this side. And then do the same thing with the 8x. Let's move it over here so it's positive, so we need to subtract 8x from both sides. Okay, so now we're basically right back in the same thing we were yesterday. We're going to solve and factor this. And we've got three terms. And again, first thing we're looking for is there anything in common? Is there a greatest common factor? I'll have an x, right? So let's take the x out. So taking 1x out, we're going to knock every power down by 1. And now we've got just x squared plus 2x minus 8. That's where we're going to look for the factors of negative 8, where the sum would equal positive 2. Okay, has to be 2 and 4. No way that 1 and 8 is going to work for this one. Since that's a positive 2 for your sum, that plus sign goes with the bigger number, bigger factor. So that positive goes here. And if you divide these two, that makes that a negative. So we've got negative 2 plus 4. That would give us the positive 2. Okay, and then one more step with that one is that if we're factoring, we were good. But for what we're doing today, we're solving, so we've got to get down to we've got x equals something. So that's where we're going to take x, each parentheses, and then set each parentheses equal to 0. Okay, for this one, it's pretty much done. Nothing you can do with x equals 0. For x minus 2, just add the 2 to both sides. And then for the x plus 4, we'll subtract 4 from both sides. And there's the three answers we're looking for. And again, we started off with x to the third, so there's our 1, 2, 3 answers that we have. All right, now here's one thing where they may kind of go back, and even on these answers, they may tie back in like we did yesterday. Once you've got these three answers, they may ask you to go back now and tell me, all right, what is the multiplicity of all these zeros that you have? All right, so if we go back up here, we had it in factored form. Basically, we're taking off the powers. X was to the first power, so your x equals 0, the multiplicity would be 1. For x equals 2, came out of this parentheses, that was still to the first power, so that multiplicity would also be 1. And with the x minus 4, that came from the x plus 4 here. Still just the first power here, so every one of these answers, the multiplicity would just be 1 on each one of those zeros. And if you remember from yesterday, the multiplicity, you're just going back to the factored form. Right before you do the last step to solve it, you're looking for the powers that's on each set of parentheses up here. And again, with the x out front, technically you could put that x in parentheses like that. Okay. Let's keep going through a few more of these. And again, we're just going to keep going through some solving. Really, this is more just a factoring review almost, because we're still going to solve equations, but at the same time, it's almost a review of the factoring. So we're just going to throw you some different things, some different special cases that we've seen along the way, and just keep working through those. All right, so for example 4, we'll go with x squared minus 10x plus 25. Okay, so this one's set up just like a regular factoring. We're looking for the factors of positive 25. And we're looking for the sum that's going to equal negative 10. Okay, and with 25, it seems like there'd be more, but there's really only two. It's either 1 and 25, which is not going to get us to 10, or 5 and 5. So it's got to be the 5 and 5, right? Since the sum is negative 10, and you may go, wait, well, which one of these is negative? It's a tie. If it's a tie and you've got both of those, it doesn't matter which one you put it on, just put it on one of them. It doesn't matter which one, because they're the same size. To find the sign of the other one, just divide. We've got a positive divided by negative, so that makes it a negative. So they're both negative. So if you factor this one, it'd be x minus 5 and x minus 5. And since we've got two of the same thing, you can really just condense that together and make it x minus 5 squared. Alright, and when you solve that one, just going to change, and you're really going to go back here for this part. You're just going to change the sign so you get x equals 5. And since there's only one answer, we'll just do the multiplicity right underneath it here. Since you've got x minus 5, basically there was two x minus 5 answers, right? Or two these parentheses here. Since we condense them together here, multiplicity would be 2. Yeah. So that's one of those cases where you only have one answer, but we basically use that answer twice because we have the two sets of parentheses here. So it's a repeat answer if you want to kind of think about it that way. Alright, example 5. Let's go with x squared minus 81 equals 0. Okay, and for this one, you can do it two different ways. What's one option? Has anybody got an answer, something that they're looking at this one and they're kind of remembering something we did in the past? Anybody got any thoughts on this one? Okay, you could get x squared by itself and then square it both sides like we did on the first example, right? So you could add the 81 over to both sides. So now you've got x squared equals 81. And then just square it both sides. Okay, so if we do that, square root of x squared is just x. And if you squared 81, that's just 9, right? And again, so we'll get the two answers. We'll make one positive and one negative. So we got plus or minus 9. Okay, so that's one option you could do. One thing you can kind of look at the beginning is it's a different option. You get the same answers. It doesn't matter how you look at it. These are two perfect square numbers, correct? And if we have two perfect square numbers, here's like the second option we could do. If we were going to factor that, you could break this off. This would be x times x. This would be 9 times 9. So you could break it off as x minus 9 and x plus 9. And when you solve both of those equal to 0, you're right back to the same answers. Because you're going to get a positive 9 here, and you get a negative 9 there. So that's one of those things where sometimes you get problems. There's more than one right way to get the answer. This is one of those problems that you could add the numbers over here, square it both sides, and you're good to go. If you look at that and go, all right, well, those are two perfect square numbers. I can break it up and do the same thing. That's fine. But you know, maybe one of those things, since we were doing this way earlier, getting x squared by itself, this might be the best route to go. That seems to be kind of the pattern that they're going to look for when we're going through this section. All right, let's give you that same kind of problem here, one little twist to it. So let's say we've got x squared equals negative 81. All right, let's do it like we did up here. We're going to square root both sides. When we square root x squared, that's just x. And again, we know that's going to be 9, but because of the negative on the inside, the only thing that's going to be different is instead of it being just a regular 9, because the negative, we're going to put an I in the answer. I know we did one like that earlier, but sometimes it helps just to see that, because they're going to keep throwing that imaginary answer out to you when we're working through these. Okay, kind of short, but still, doesn't hurt to see those at least a few times to get comfortable with them. Okay, now here's where they're going to start changing things up a little bit. It's still some stuff we've done, but they're going to kind of tweak it just a little bit. So we're still going to be factoring, we're still going to be working through problems, still kind of doing everything we've done here in the first few examples. But this is where they're going to tweak things just a little bit. So let's go with x squared minus 1 and then x squared plus 4. So for this one, it's not just x minus 1 and x plus 4. We've got the squared, which brings in just a little bit more degree of difficulty here. Alright, so it's already partially factored. So we're going to go ahead and kind of break it up into two separate parts. That we've got x squared minus 1 equal to 0. We also have x squared plus 4 equal to 0. And now that you've got these two separate parts kind of set up here, we can do that just like we did on example 5. Because we've got x squared by itself, let's just take the numbers and move them over to the other side. So for the x squared minus 1, let's just add 1 to both sides. And if you have x squared equals 1, we'll square root both sides. And if you square root 1, it doesn't really do anything, right? It's still just 1. So that one, it could be positive 1 or it could be negative 1. And we'll do the same thing with the 4. Subtract the 4. So we've got x squared equals negative 4. Square root both sides. And again, the only difference with this one is it is a negative 4. So in your answer, instead of just being plus or minus 2, the negative means we put the I in the answer. So there's one where we're still doing the same things we were doing before, working through the parts. You've got x squared, but it's just in two separate parts, so we're getting two real answers and we have two complex or imaginary answers. So that's where they're going to kind of take what we've done and where we've done it in separate parts and just bring it in, but it's just going to change that just a little bit. Okay, and for example 8, this is one that's, we're going to, again, kind of changing things just a little bit. Something different, because we haven't really talked about x to the 4th yet. Alright, here's what you want to look at. We've only got the two terms. We've got x to the 4th and we've got 16. I guess here's kind of the question on this one. 16 is a perfect square root, right? That if this was x squared minus 16, we could do we'd have the difference of two perfect squares. So in this case, this one's kind of a little bit of a tweak here. X to the 4th is still a perfect square. That to make x to the 4th a perfect square, you can think about that as being x squared times x squared. And of course 16, we can make that 4 times 4. You know, we got that part. So it's still a perfect square problem. It's just it's a kicked up degree of difficulty. So it would be just like if it was x squared minus 16. That would be x squared would be x times x. In this case, it's x to the 4th. So now we can make it x squared times x squared. So here's one where we have to kind of break it up into parts. So perfect square wise, this would be x squared times x squared. The 16, then we could break it up as a plus 4 and a minus 4. And once you got it down to x squared, well, now it's like the problem we had on example 7. That if you get it down to x squared, you can just set both of those x squareds equal to 0 and solve the two things. So this one takes you that one extra step to get there. So we start with x to the 4th, and once we break that up as two perfect squares of x squared and x squared, now we've got this, and now you can separate the two parts. And to get the x squared solved, again, we get the the x squared by itself, so subtract 4 from both sides. And as long as we're dealing with x squared and a number, we're going to square root both of those numbers. Square root both sides, you get the x equals plus or minus 2, and again, because it's negative, put the I variable in there. So there's two answers. And then we'll get the next two from this part that we'll add 4 to both sides. Square root both of those numbers. And with just the regular 4, it's just a plus or minus 2. No I needed for that part. So hopefully you're kind of seeing that with the examples we're doing, they keep stressing the square root property on this one, that you're going to get x squared. If it's just x squared and a number, the easiest thing to do to get the solutions is just get x squared on one side, the number on the other, square root it. And again, if it happens to be a negative, just make sure you put I in the answer. That's all you have to do. All right, now here's where we need to here's where we're going to pick up something new that we haven't talked about yet at all. With example 9, here's where they change things up from everything else we've done so far. Everything up to this point, we either had 2 terms or we had 3 terms. Example 9, well, we've got 4 terms. And now the difference is, we've had some in the past where we had 4 terms. We can combine like terms and do a few things with it. There's nothing you can do to combine any like terms, because this one's x to the 3rd, this one's x to the 2nd, this one's x to the 1st, and this one doesn't have an x and all. So a little bit different on this one. So we've got 4 terms. And anytime you have 4 unique separate terms like this one is, you've got really one options to do here. Anybody remember what to do with 4 terms? It's a special kind of factoring. Now that one you still use 3 terms for that one. And you may, once we say it, you may know what it is. To factor 4 terms, you must use factor by grouping. Okay, anybody remember hearing that one at some point in time, maybe? That doesn't ring any kind of bell at all? Maybe. If not, I think when we see it sometimes, people will kind of go back and remember it. So basically, here's what you do for factor by grouping. You group the first 2 terms together, and then the last 2 terms together. So we're going to take x to the 3rd plus 5x squared and put those 2 things together in a group. Now, and the one thing I always tell people to do, and this, if it's all positive, it's a little bit easier, but when I start throwing negatives at you, the best thing to do is always put a plus sign in the middle, regardless of what this sign is in front of the x, and then take that positive 4x here, and then the positive 20 there. Because sometimes if that number happens to be negative, some people kind of leave it on the outside. But I tell people, if you think about separating it, as it's always going to have a plus sign in the middle. Sometimes that helps with making sure everything gets to where it's supposed to be. So take your first two terms, put them in a group together. Take your last two terms, put them in a group. And then find the GCF of both groups. Or find the GCF of each group. So for this one, we've got x to the third and 5x squared. Number-wise, there's no numbers, but they both have x's, right? Take out the smaller amount of x's, that would make it x squared. So for x to the third, if you take two of them out, you're left with 1. If you take both of these out, you're left with just the 5. Okay, so there's your first set. Second set, it's 4 and 20. What can you divide both 4 and 20? Do it 4, right? So take the 4 out. Take 4 divided by 4, that's 1, or just x. 20 divided by 4 would be the plus 5. Now, here's the great thing, if there's any great thing about the 4 terms. If you do factor by grouping, and if these two things in the parentheses aren't the same, you know you did something wrong. Because if you do factor by grouping, these two things will always be the same. So if you get back and you've got one of these as x plus 5 and the other one's x minus 5, that lets you know that, okay, I got something wrong with my signs. There was something that was off here. You know, or sometimes people get to this one, they'll have a 2, and then they'll tell me that this was like 2x plus 10. Well, that just lets me know you didn't take out enough. You took out 2, but really you could have taken out 4. So these two things have to be the same. So that's your check. If they're not the same, you did something wrong. So you know right off the bat whether you did something right or whether you did something wrong. Once you've got those two things the same, everything is good, then what you're going to do is you're basically going to kind of go ahead and put the x plus 5 parentheses that's back here. And then you're going to take whatever the two numbers were in front, which was the x squared and the 4, and those two numbers get their own set of parentheses in the front. So they're going to go right there. And this was still equal to 0. And now that you've got it here, well, now you're going to solve each parentheses. You're going to do x squared plus 4 equal to 0. And then you're going to do x plus 5 equal to 0. Okay, and this one should be pretty easy, right? Just change the sign, just subtract 5. So x would be negative 5. And for x squared plus 4, that one's got just the x squared. We're going to get x squared by itself. And hopefully by now you're going, well, we've done that like 6 times already. Yeah, we're still doing the same thing. Once you've got the x squared by itself, we're going to square root both sides. And when you square root the negative 4, that's going to be plus or minus 2i. Okay, so 4 terms. That's the one thing, and again, you may have done that in algebra, but that's been at least a year, sometimes 2 years ago for some of you. So that's one of those things that if you have 4 terms, you're going to do factor by grouping. And if you do a couple of them, it gets pretty easy because you just group the first 2 terms together, put the last 2 terms together, and then you're just looking for the greatest common factor. And as long as you pull out the correct greatest common factor, those 2 parentheses will be the same every single time. If those aren't the same, you know you didn't pull out the greatest common factor. And that's really what it comes down to. Okay, and then one last thing, and this may be, there may be one question on the test with this one and maybe one bonus question. So this is more of, if it's a 20 question test, this will be one question and maybe an extra bonus question at the end for this part. Because this is a special kind of factoring. It's its own separate, unique little thing. And they're really similar, but there's just a small little difference between the two. So the special factoring we're looking at, there's two types. We're going to do the sum of two cubes. And then we're going to do the difference of two cubes. And I'll go ahead and show you what this one is. Now, the thing is for this one, so if it's the sum, that means we're going to add, and if it's two cubes, we need two things to the third power. So we've got x to the third power and y to the third power. Here's what's kind of different about this one. This is one of those things that you have a little formula. You plug the numbers into the formula, and that's it. There's really nothing else you can do with it. So it's almost one of those odd things that you don't really get a whole lot of simplification on this one. It's just its own special little case. So here's what it is. If they gave you this one and asked you to factor it, it would be x plus y. And it would be x squared minus xy plus y squared. And if they gave you this one and asked you to factor it, that would be it. This looks like that you could do more to this thing, but that's as far as this one would go. And we'll give you almost some numbers in it here in just a minute to show you. If it's the difference of two cubes, it's the exact same setup. We're just going to change a couple of signs. So if it's the difference, we're just going to change that x cubed plus y cubed, change it to x cubed y cubed. Letter-wise, the letters are going to be the exact same letters. We're still going to have an x, still going to have a y, still going to have an x squared, still going to have the xy, and you would still have the y squared. The only thing that changes is the first two signs. These two signs in the beginning flip-flop. So we're going to put the minus here, and the plus goes here. That last one always stays a plus. Now, the good news is, this is one of those things that it hardly ever pops up. It's one of those things that every now and again it will pop up when you're doing these. So it's one of those of more of just, as long as you kind of see it and you kind of memorize it, and it just rattles around in your head a little bit when you see some of these in the future, that's kind of the biggest thing. So it's not something, it's not like a lot of factoring things we do. These are some things you just want to kind of have there in your memory, that at least you kind of remember what's going on with it. So, all right, here's what we'll do. We'll go through a couple examples, just so you make sure we got it. Okay, so they're going to ask you to do this. Factor x to the third plus 125. You're going to say that's it? Yeah, that's the problem. That's all it's going to be. This part back here is going to be your answer. So here's what we're going to do. You've got to figure out what this thing would be cubed. So we've got x cubed, so we're good here. But 125, that would be the same thing as 5 to the third power. So everywhere we have an x up here, we're going to have an x here. But everywhere you have a y, you've got to take that y and replace it with a 5. And that's what you're going to have to kind of go through the setup on this one. So we're going to take this formula that's here, and everywhere we have a y, we're going to replace it with a 5. So we're going to have x plus 5 still going to have x squared minus x times 5 plus 5 squared. Okay, so again, everywhere we had a y, we're taking out the y and replace it with a 5. Because the x was okay. We didn't do anything with the x part. And once you do that, there's really only a couple of small things that you can do. X plus 5 is okay. The x squared is good. Where you've got x5, we normally put the number first, so just reverse that around, make it 5x. And then do 5 squared and make it 25. And that would be the answer you're looking for. And most people look at that and go, well, that's worse than I had in the beginning, because in the beginning I just had this. Now I've got this thing that's, twice as long or 3 times as long. It is, but we'll show you in a minute how we actually get an answer off this part. Okay, so there's one we're going to do the plus. We'll do one more with the minus. So let's change the letter up here for this one. Let's do t cubed minus 64. So the very first thing is you've got to figure out, well, what's the two cube numbers here? Well, obviously this one's t, so we're good there. 64, though. And again, the numbers will have to be pretty small. Just go through your list of numbers. If you did 2 times 2 times 2, that would be 8. If you did 3 times 3 times 3, that would be 9. If you do 4 times 4 times 4, that's where we get 64. So 64 is the same thing as 4 to the third power. So in the other problem, formula up here, we had x cubed minus y cubed. Everywhere we had x now, we're going to replace it with t. Everywhere we had a y, we're going to replace that with a 4. So we're taking the x, replace it with t, take the y, replace it with a 4. So t basically becomes our x, and then this 4 is basically what we're going to replace with y. Okay, so the formula we started off with was x minus y. So we're going to do t minus 4. Then it was x squared, which now is going to be t squared, minus x times y, so it's t times 4. And again, just so we can kind of maybe save one step here, instead of doing t times 4, let's do 4t. And at the end we had y squared, which is going to be 4 squared. Again, the only thing you can really do is take that 4 squared at the end and make it 16. And that would be the final answer that we're looking for. And again, it doesn't look like that's a lot, because it looks like it's a lot longer than what we started with. But if you put it in factored form, that's what you can do. Now, here's where we're going to add one little step to this one, and this will be the last thing that we'll do. Is if you have something in factored form, like we've got with this one, if they ask you to solve this one, because it's in factored form, we would take both of those two parentheses and set them equal to 0. So we've got t minus 4 equal to 0. You also would have t squared minus 4t plus 16 equal to 0. Now, there's good news, bad news in this case. Good news is, this one's really easy to solve, right? You add 4 to both sides, we've got our answer, we're good to go. So there's one solution. Here comes the bad news. There are no factors of 16 that will get you to negative 4. There's just not. I mean, you can go through the list, you can do 1 and 16, that's 17 or 15. If you do 2 times 8, that's either 10 or 6. If you do 4 and 4, that's either 0 or it's 8. There's nothing that's going to get you there. So for this one, you would have to use the quadratic formula. Now, in this case, instead of being x, it would be t, because they changed the variable on us. So in this case, t would equal the different parts here. And so we'll set this one up, and this, again, will be the last thing we'll do here. Okay, so that's our t value. We're going to do minus a negative 4, plus or minus negative 4 squared, minus 4, times A times C. And all that's over 2 times 1. Okay, so first thing is you've got the minus negative. Let's get the easy part out of the way first. You've got minus a negative 4, so that's 4. On the bottom we've got 2 times 1, that's 2. And for the rest of it, we're just going to work it out here. Actually, let's put that on the side over here just so we can save a little room. If you do negative 4 squared, that's going to be 16. Minus 4 times 1 times 16, that's a minus 64. So we do 16 minus 64, that is a negative 48. Okay, so if we work everything on the inside, that's called the discriminant. If we work the discriminant down, we get negative 48. And we're not going to have any real number answers, but we are going to have some imaginary answers because of that negative 48. If we did negative 48 and broke it down, we could do 2 times 24, which would be 2 times 12, which would be 2 times 6, which would be 2 times 3. Okay, so we got 1, 2, 3, 4 2s. And we got the 3. So we're still looking for the pairs. There's a pair of 2s, so that 2 is out. Another pair of 2s, so that 2 is out. And that 3 stays on the inside. So that becomes a 4 square root of 3. Now the only thing that makes this one a little bit different is because the square root was negative, that's where we're going to put I in the answer. So we can put the I either anywhere in here. As long as it's not underneath the square root, we're okay. You can put it here behind the 4. If you want to, we can put it behind the 3. So it's 4 square root of 3I. Okay, and this is all over 2. And this is where they're probably going to ask you to break this thing up into 2 parts. So we've got 4 over 2 plus or minus 4 square root of 3 over 2 with the I at the end. And the good news is the 4 and the 2 cancel, right? So that's 2. That 4 and 2 also cancel. So your 2 answers here would be 2 plus or minus 2 square root of 3I. And way back up here in the beginning, back up off the top of the paper, we also had that t was going to equal 4. So there's your 3 solutions we're looking for there. Now, I know that's not very pretty, but that's what we're looking for if they ask you to solve on those. Now, you're not going to get a whole lot of solvings. That probably would be the bonus question on the next test, that you actually have to go back and solve and go through the steps, because it is a long process. You got a lot of work to do there.